Hello students, this is the fifth video lecture about the PCB design. So today we are going to discuss about the mechanical design of PCB, uh, types of boards and mounting techniques, and very important, the stress analysis of the PCB board. So this is already discussed in my previous lectures. Why PCB and why the advantages of PCB. So the again I'm recalling this thing. PCB board, it will be reduce the size of the device and weight and high repeatability and very less wiring errors must be there in the PCB and easy inspection and maintenance. So these are the key features, and you can tell it is a key advantage of PCB board. So the most important thing, the mechanical design of PCB. In the mechanical design, first is coming to this point, it is the called board size and shape. That means uh, at the starting of the lecture, I already told that the main advantage of the PCB is it will reduce the size of the device, and also it will not be so much bulky. So for this reason, I have to find out how in the small area I can able to uh, introduce much more components without compromise their efficiency. So for this reason, the board size and shape is very much important. So determined by enclosures, constraints, component density, and manufacturing panel limits. So this is the thing of board size and shape. Next is the mounting features. It includes mounting holes, clamps, brackets, heat sink, attachment points, positions for structural support. Heat sink is very much important in any electronics component. So much heat up will be there during this operation. How I can absorb this heat, or how can I release the heat? For this reason, cooling is a very much important thing. So heat dissipation path, vibration resistance must be designed in form of start, not added as an afterthought. That means we have to find out any system which will cool the device and cool the all the components. So heat sink is very much important. So for this reason, so mechanical design, we have to keep in the mind this type of criteria. So what are the mechanical design considerations? First is geometry and layout, optimal board size. That means match manufacturing panel limits, enclosures, dimensions to minimize waste and stress. And mounting arrangement, place holes, brackets, and clamps to distribute mechanical loads evenly. That means mechanical load, if it is uh, not balanced, so it can able to crack the PCB board. So for this reason, this thing, the all stress all component stress and mechanical vibrations, some other vibrations are there, and temperature equality in a board, it must be uniformly must be distributed. Otherwise, it can crack down the PCB board. Also, the component mount, it can hamper the component mounting system like. And installation type, PCB may be mounted vertically or horizontally depending on airflow and space. Next, thermal and serviceability. Components fixation. Heavy components, transformer, large capacitors must be mechanically secured. That means secured means it the arrangement of uh, mounting, it must be perfect. Cooling method, heat sinks, thermals, uh, uh, arrangements. Uh, it's like that. The sink must be absorb the heat. It release the heat like that. Next is accessibility. Adjustable components, connectors must remain reachable after assembly. Next is components area and volume planning. So before we start the PCB uh, fabrication, we have to design the PCB. In my previous lectures, I already told there are different types of softwares are available in the market, which will uh, give you, with the help of the software, you can able to simulate the circuit. After that, up to PCB design, you can able to see through the software. So after that, I told at the end of the simulation, you can able to download the Gerber file. In this Gerber file, this type of design you can able to find out. So in this design, you can able to see that your virtual design of PCB board. So this, if you see the design, uh, you can able to see how your PCBs looks like in the future when you fabricate the PCB, how your PCBs looks like. So so this is a projection. You can tell that this is the projection. This is the future assessment. So how the all components is mounted, how the space, how much distance, how much space it is must be give between these two components. This type of arrangement, this type of thing, you can virtually you can assessment, and with the help of softwares. So for this reason, the component area and volume planning you can do with this simulation. And many softwares are available in the market. It will give you this type of design before fabricate the PCB board. Okay, for this reason, you have to see like that. Okay, and you can able to plan your device area, device components, everything. So in previous lecture also I have told there are different types of PCBs are there: single-sided PCB, double-sided, multi-layer, rigid, flexible, uh, rigid, flexible, and both rigid and flexible both. So all PCBs are available in the market. As per your use, you have to uh, take care what type of PCB is needed for your device. You have to um, decide, plan it. After that, go for the design, go for the fabrication. So there are different type of mounting techniques are there. Edge support rule, support spacing, mounting method, design goals. There are different types of things there. Uh, Edge support rule is nothing but a provide mechanical support within 25 mm of all board edge. Support spacing means install intermediate supports every 10 centimeter across the board span. Mounting methods, common approaches including screws with stand-offs, naps in clamps, card edge guides, and there are different types of things out there. Design goals, if we go for IoT connection, if we go for some other special any connections are needed, special any connectors you have to include into this PC board. This thing also you can able to introduce, but before that you have to need some planning, need some design. So this is the mounting considerations, board size and shape, shielding requirements. These are the very important thing. What is needed in the PCB design and PCB fabrication. IO and serviceability. IO means input output. What type of input connections you have to introduce in the PCB? What type of output connection you introduce the PCB? For that, what type of connectors you need to install into your PCB board? It may be it may be USB. It may be some other connectors. All you can able to introduce, and very important, heat dissipation, because for you when the PCB board will operate automatically, the components will generate some heats. So these heats will actually reduce the efficiency of the device. So with the help of proper heat dissipation method, you can able to uh, increase the efficiency of the device and also the longevity of the device. Okay, so for this reason, heat dissipation is very much important. Heat sinks are very much important in every PCB board. Uh, it is very much important. Next is the stress analysis. So it is very much critical because uh, small thick PCB rarely experience significant stress under normal condition, but the large or thin boards, some flexible boards, they are feeling the stress because so many components are there in this, suppose in particular PCB, or the is the board you are using the flexible board, thin boards. So in that time, so much stress from it came, it may maybe come from the components, and it will affect the um, your operations of circuit. So for this reason, we have to, first of all, we need to measure it. First, everything we need to measure it. After that, we take the proper correction. Uh, we need to proper corrections uh, for this stress. Boards with heavy components, transformer, large capacitor requires stiffener or supports near the load. So boards in automotive, aerospace, or industrial environments faces sustain dynamic loads. So for this reason, we have to need the stress analysis also. Like the PCB board design, the approaches and another planning you need about the stress. So there are different type of softwares are available in the market. Ansys, COMSOL, Multiphysics, so many softwares are there. Before you design the PCB board, you can able to uh, measure the stress. Before you fabricate the PCB board, you can able to measure the stress through some design. So you design the board. After that, what the stress is there, you can able to find out. So many softwares of what I told you, console multiphysics and so many softwares are there. Through the softwares, you have to find out the what the stress of the board, and really this stress can able to This really this PCB board is able to sustain this stress. We have to find out. So because the it is not a just one time fabrication. This is not a one time use actually PCB board. That means several when you're going to introduce any PCB board in any device. So minimum many years you have to use this device. So no, not it is a one time or two time, and not it a use and throw. This is a costly electronics. So for this reason, the stress analysis is very much important. Okay, place heavy components near mounting points or stiffeners. You use thicker board material or add local reinforcement. Avoid placing brittle components near boards, edges, or mounting holes. Uh, Run FEA, finite element analysis, on complex or high reliability designs. So this is the software part you can able to find out. So there are different types of stress and testing method. Type of stress: mechanical, vibration, thermal, environmental. Mechanical means some mechanical stress will give. Vibration means some vibration frequency will give to the board, and after that we check the efficiency of this device. It is really effect or not, how it's sustained. Next is thermal. How the thermal management is there in the device. Artificially we give to the some temperature to the device, and investigate the efficiency of the PCB board. So and another is environmental: humidity, dust, corrosive atmosphere degrading the material. So how it's maintain it, how it sustain it. So this thing we have to find out. Okay, so thank you everyone. Everyone, again I am going to thanks my students uh, actually who prepared this presentation, and due to them only I can arrange this video. So thank you.